Okay, hi everyone. Listen here. In this video, we are going to be factoring linear expressions. We're not going to be eating pizza, maybe later. Um, but before we get to factoring linear expressions, I want to remind you of where you've seen factoring before. Remember back in the day when you had factor trees and you were given a number like 24 and you were asked to factor it? And you did something like this. Wrote 3 and 8. Now, why did you do this? Because 3 times 8 equals 24. That is, 3 and 8 are factors of 24. You could also have seen it this way too. If you had a rectangle and it was 3 inches this way and 8 inches this way, and you were asked what's the area inside, well, you'd simply write 3 inches times 8 inches equals 24 inches squared. The point simply is here, is factoring is taking, well, we first did a number and breaking it apart into two or more factors. Well, we're going to do the same thing now, except we're going to do it with linear expressions. So first of all, what makes something linear? Well, things that are linear have a variable in them, but they only have, the variable only goes to the power 1. So all of these here are going to be examples of linear expressions because the exponent in all these is 1. And they're expressions because, we have at least a variable involved here. So we're going to first do this visually. And I'm going to remind you, like we did in class, then we drew these before. And when we did, we had an open square was worth 1, and a closed square, a shaded square, is worth -1. Likewise, an open rectangle was 1 by, had a length of x. So this was positive x, and a shaded rectangle was worth -x. So these were the 4 pieces we worked with, and I'm going to be bringing some other pieces here in now. You'll see what's called algebra tiles in many places, and they're usually, you'll see little squares, some rectangles, and maybe some bigger squares. And they come in different colors. These particular squares here are green, and these rectangles are yellow. And with these, we're going to call these positive 1. So there's still 1x. But the yellow rectangle is going to be with x, and the green squares here are going to be worth 1. One thing I want you to notice right away about these is if I line up 3 of these green cubes, they're not the same length as one of the rectangles, right? Or if I did 4, right? So 3 of these squares is not the same as one of these, and that's on purpose. So when we go to manipulate these, we always want to kind of line these things up this way because they are the same dimension this direction. That is 1 by 1 and a 1 by x. Okay, so these are my x pieces. These are my 1's pieces. In this case, positive 1, positive x. All right, so let's use these things now to factor 3x plus 12. So what that means is I need 3 x pieces, right? I need 12 of the 1's pieces. There's 2, there's 4, there's 6, there's 8, 9, 10, 11, 12. So my goal here is I want to arrange these pieces into a rectangle. So let me write that down. Arrange the pieces into a rectangle with no, a complete filled-in rectangle. Arrange the pieces into a rectangle. So that might take some, well, one thing I know, I want to turn these things this way. And I notice I have a 3 line up there. Well, I can put 3 this way, can I? And if I continue that, I can go like this. It doesn't look like a rectangle. It looks like I need to move this piece over here. And oh, that looks like getting close. And boom. Oh, there we go. There I have a rectangle. A completed rectangle. This is what I'm after. So this is my 3x's and my 12 pieces. I'm going to use this now to factor 3x plus 12, because that's what represented here. What I want to do is I'm going to look on my sides, and when I look this way, I'm making a mess of things. How long is this side here? Well, I can see it's a 1 and a 1 and a 1 on these ends. These ends are worth 1. So this whole side is worth 3. When I look this way, matter of fact, let's go like this. Let's go, boom. We'll draw a line here for this side. We'll draw a line here for this side. When I look this direction, I see I've got this piece here, which is a length of x, and then I've got a 1 piece here, a 1 piece here, a 1, and a 1. And so if I want the length of the whole side, I have to add up everything. That's a plus, 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 plus. So what I have here is x plus 1, 2, 3, 4. Let me write that. X plus 4. So what I've got here is I've got a rectangle. I'm going to move these things to one side now. I've got a rectangle whose one side is 3, and whose other length is x plus 4. These are my factors for 3x plus 12. That is, 3x plus 12 is going to be equal to 3 times x plus 4. Now, is that true? Well, I can check it by distributing, because 3 on the outside of the parentheses means to multiply, so I'm going to multiply it by that. I distribute, and I have 3 times x plus 3 times 4, 3x plus 12, and that is exactly what I was trying to factor. That is, I broke 3x plus 12 into 2 pieces. I'll write it one more time, 3x plus 12. I broke it into a piece that's 3 times a piece that's x plus 4. And that's it. That's the factor formulas. I know this is the factor form because I can't break 3 apart anymore, and I can't break x or 4 apart anymore. So the factored form of 3x plus 12 is going to be 3 times x plus 4. So this is doing it using manipulatives. But let's do it another way, that may be a little faster. What I'm going to do is I'm going to just draw a rectangle. All right? I'm going to draw a rectangle, and I'm going to break it apart into 2 pieces. One piece is going to be 3x, and the other piece is going to be plus 12. And I ask myself, what's the most I could divide 3 and 12 by? What's the biggest factor I can divide into 3 and 12? Well, the factors of 3 are 1 and 3, and 3 is certainly a factor of 12. So the biggest, that is my greatest common factor for 3 and 12, is 3. Now, 3 times what gives me 3x? Well, x does. So 3 times x is 3x. Right? That's this first square. And I ask, 3 times what gives me 12? Well, 3 times 4 gives me 12. Matter of fact, because this is positive, it's going to be plus 4. So here's the same thing again. So 3x plus 12 in factored form is 3 times x plus 4. Just like that. So another way we can do this is like this. So I want to factor 3x plus 12. I can just simply ask myself, what's the greatest common factor of 3x and positive 12? Well, the answer there, the GCF, is going to be, greatest common factor is going to be 3. So that means I can divide both sides by 3. 3x divided by 3 is going to be x, plus 12 divided by 3 is 4. And what I divide by is what's going to go outside. So 3 times the quantity x plus 4 is the same thing as 3x plus 4. 3x plus 12. Oops, excuse me, I said that wrong. So this is my factored form right here. Let's put a highlight around it. This is my factored form. And we'll practice some more of this here in a different video, or certainly do it in class. Hope this helps.